Amitabh Mukherjee from Department of Physics, Delhi University, and Maithili Sharan sir from IIT Delhi. So students, they will give you the tips from their subject, and it is really you that आज आपके साथ कितने लर्नेड लोग हैं और आप इनसे कुछ सीखेंगे. So I welcome our guests. You are really campus of my lecture now. First of all, we will start अपनी माँ सरस्वती को नमन करते हैं. And before starting, we would like to present a class with who are अपने प्रज्वलित करें. Mukherjee sir and Maithili sir with us. हम सभी स्टूडेंट्स हैं यहाँ, इवन मैं, क्योंकि सीखने के लिए कोई उम्र नहीं है. तो हम सभी स्टूडेंट्स माँ सरस्वती को नमन करते हैं कि वो अपनी कृपा हम पर बनाए रखें, हमारे को आगे बढ़ने का इस पथ पर हमेशा मार्गदर्शन करें. We offer our prayer to God that she enlighten our minds with knowledge and wisdom. या देवी सर्वभूतेषु विद्यारूपेण नमस्तस्यै 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 नमो नमः.
तो पढ़ानी है और फिजिक्स केमिस्ट्री में है वे दिए. अच्छा सर, हाँ वो बुकलेट, हाँ ये दे लो. आइए सर. यस सर.
Internship Science Camp 2024. And students, I want to tell you that campus में पहले भी में, उसके बाद 2022 में और अब फिर 2024 में हम प्रोग्राम का दोबारा आयोजन कर रहे हैं. ये सब माँ देवी सरस्वती की कृपा है, जिनके कारण हम इस ज्ञान के को प्रज्वलित कर पाते हैं.
मिनट ना
अमित जी चलाओ कहाँ है on? हेलो हेलो Children, you are all heartily welcome in this DST Inspire Internship Camp. We are with us the reputed professors from Delhi. Professor Amita Mukherjee is Professor of Physics in Department of Physics in Delhi University. He will deliver a talk on cosmology. And we are with us Professor Mathi Sharan, who is a Professor of Mathematics in Department of Mathematics in IIT. So you will learn and will seek great guidance as well as inspire from the talk from them. We'll start in just a few minutes. Just let's first of all honor Professor A. Mukherjee sir with
कैमरा
so you are heartily welcome.
जल्दी जल्दी
Professor A. Mukherjee.
सर MIT के प्रांगण में आपका बहुत बहुत
वीडियो कर देते हैं ना
Sir, this is a memento of love and gratitude from our side. Thank you so much, sir. Thank you so much, sir. It's such a pleasure.
मूवमेंट
Now we welcome Professor Mathi Sharan sir.
Now we welcome Professor Mathi Sharan. आपका भी सर MIT के प्रांगण में बहुत बहुत स्वागत. Thank you so much. So now we have Professor and he will deliver a lecture to you.
इस पे भी चलेगा उनकी पीपीटी भी चलेगी ना
चाहो तो बोलना माइक
इसमें ये वाले माइक में लगा माइक
ये लोग काम कर रहे हैं, तो मुझे वो शेयर कर दे लिंक।
कर दिया।
ये चार्ज है ना, इसका बीच में हमें मिलेगा टाइम, फिर से चार्ज कर लें।
तो अभी तो लगा ही रहा हूँ। इसमें तो सेट भी नहीं होने का ये। एस पी नाइस के रहने सेट भी नहीं होने का इसका।
ठीक है।
बैठ जाने भाई। अच्छा केवल स्क्रीन कह रहे हो हर किसी को ना अपनी अपनी कुछ ना कुछ डिफरेंस है। किसी की शार्पनेस अच्छी है, किसी की कलर अच्छे हैं, किसी की स्टेबिलिटी अच्छी है, वो डिपेंड करता है अपने सेक्शन
इनको कॉलम माइक लगवा देते
सर कॉलम
सचिन वो कालो माइक
नॉर्मल ऑडियो को रिकॉर्ड नहीं करनी, सारा सेशन यूट्यूब पे और हमें इसलिए यूट्यूब पे सुना इसका साउंड तो साउंड क्लियर आ रहा है कुछ और
जैसे वो बोलेंगे घूमते फिरते वो लगा रहे हैं, वो तो
अरे बेटा नहीं वो साउंड में आएगा और साउंड से डायरेक्टेड करेगा।
हमें वही स्पीकर को कॉलम में लगाया था, तो जो घूमते फिरते बोलता है।
हाँ स्पीकर को होना चाहिए था हमारे
इससे इसकी जरूरत है।
हाँ हाँ तो होना चाहिए।
Good morning, everyone.
साउंड की आवाज़ बढ़वाता है।
Namaskar. So what you prefer, Hindi or English?
साउंड की आवाज़
इंग्लिश
इंग्लिश
Okay, for I think I am going to application of mathematics in solving the real life problems. Okay? So I am sure from your childhood you are reading mathematics everywhere. If you recall, you will find lecture. It will be subgroup applications which you are using from your childhood. Then applications, models coming from the health sector, atmosphere, air pollution. So let us start. Mathematics used everywhere. Starting from your market, cricket, see, satellite, government space technology, everywhere we find its applications. In fact, there are the unlimited applications. Just give you the similar, even very small child, when he starts, we know chocolate. He just get the chocolate, then go to the shop, then he gets them very clearly. Either he will get, depending on the price, easily he can get the top. Now when you grow, you just see the generalized applications, then you are asked to buy the milk, grocery from the shop. Certainly, when you go and buy the vegetable, nowadays of course the system has changed. It is people place the order and everything online. But still, your parent asks you to bring you half kg apple, this much Loki, and so on. You are giving the 100 rupees note, and then you will get these two items, let us say some apple, half kg apple, one half kg Loki. And you know the cost of the Loki, you know the cost of the apple. Certainly you will calculate how much it will cost you, and you are giving the 100 rupees. Certainly will verify how much that you are getting back. So all involves basically the concept of mathematics itself. This which you have seen from your childhood, as you grow in the college or in the school, you are given a project. You are given a project, and that project you are asked to complete in a certain amount, days you are given it. Let us say you are given the 15 days to complete a project. Okay. Then the question arises, how many hours every day you must put into it so that you should be able to finish this within the given time frame of the 15 days. Okay? And all these such concepts you have already done in your school education. Take time. Okay? Similarly, you can generalize this concept. Again, group concept. Same project is given. Now rather than you are doing that individually as your own, it means the more than one people, for example 2 or 3 people, they are in the group doing the same project, same amount of the efforts. Certainly would like to know in that case how many hours again both of the group of the people they should put into it so that they should be able to finish this one. Certainly they will take the less time. Okay? This is simple. These are some simple examples where you have been using the mathematics very clearly in your education, school education. Then you can generalize. Just see the construction of house at your home by your parents. See how many concepts are now involved, much more than this. If your parents, they want to construct the house, what you need, how many steps are involved, mathematical steps are involved with it. First, certainly your parents will not start immediately constructing the house. They will see how much money they have in the pocket. Before that, they will prepare a kind of estimate, how much cement is required, how much steel is required, how eventually before that, how much area they would like to construct. See the number of constants involved into it, and accordingly, they will hire how many labor, how much labor will be there, what is the time frame, whether he would like to have the house ready, whatever the constant it is, within the 1 month, or they have the sufficient time that they can allow the period to be 1 year. Accordingly, first aspect, estimation. Once you have the estimation, then the construction. This is a simple problem starting from home. And then same thing is moving to the society, the construction of the bridges, construction of the road, how the government provides the tenders, how these contractors, you see the same concept is generalized in the form of the models. For example, we would like to construct a bridge. Now, construction of bridge is a multifaceted problem. First problem itself, when you are constructing the bridge, you have to look structurally. You have to look at the design. How much load is going to be here? What is the present load? What is the expansion you are expecting? For example, you have just seen your expressway coming from Delhi to Meerut. At the moment, there is not too much traffic on it. There is sufficient margin. But in the years to come, you will certainly find a lot of traffic on it, lot of load on it. Okay, so you have to keep in mind that by preparing a design, okay, how much load it can carry. You have this design, then again, as in the case of the construction of house, you need to estimate it. How much estimation will be involved, how much budget, accordingly you submit the tender, okay, then you execute it. So all this involves the mathematical models. Same mathematical concept which you all done in the case of the school education, except the design part. Design part is the structure part, that is much more complex, it comes into the engineering. Okay, so this is simple model. Then go to the banking sector, for example. Banking sector. Now, certainly, you know, in the banking, when you put certain amount of the money, what is the rate of the interest, for how many years you should put it, and how much it will be, whether it's a simple interest, whether it's a compound interest. Okay, they have to have very simple models, which all you are familiar with in your school education. Okay, in the school education, this, in addition to banking sector, so let us see, now we go to the, I just take out from your school education now, let us go to today's technology. Today, you know, financial investment, stock market. Stock must have heard, many people, I think, आपके घर में भी कुछ लोग पेरेंट्स आपके करते होंगे. अदरवाइज इस एरिया में हम लोगों के कहा जाता है लॉटरी सिस्टम, कि लॉटरी लगानी है कि नहीं लगानी है, कौन सा नंबर लगाना है, कितना पैसा लगाना है, ठीक है ना, ये देसी भाषा में है. अदरवाइज शेयर मार्केट, you must see how they decide whether to put the money, invest it. So what is the idea? We have the model, we have the last year history of this one. For a particular company, you know how this company per share is performing, how is its health, and accordingly you invest it on that. Accordingly you invest it. So based on this, so in the stock market, what we call today's concept of financial mathematics. It has the many mathematical tools into it. Financial mathematics, time series analysis. Okay. Based on this, we make the probability analysis, sampling theory. All these things, some of these techniques, which you learn when you go higher. So this all you are used in the stock market. Similarly, look the cricket. Everyone may be surprised how the mathematics coming to the picture in the cricket. See the think over it. In the various concepts, how the cricket, you can make use of the mathematics in the cricket. Now, various aspects are involved into it. Let us have a simple one. When a bowler, when he ball it, what is goal? That the ball should hit at the right place. Okay? And he should be able to get his wicket. That is his goal. But what is the concept behind it? You must have heard the projectile motion. I am sure. You have make use of the, what is the angle at which you throw the ball? It just hit the target at the right place. Okay? This is the idea of the, when he is batting it up or bowling it up. And the person who is batting it up, what is why? To get as much run for his team. He should be able to hit at a larger distance. And the safety at the same time should not be out. Again, same concept from the projectile motion. This is what the other aspect, when you just see which player is performing well, and which team is doing well. It's all statistical analysis. You have the data. What about the team? For each of every individual player, you calculate the mean, average, how it's performing, then related performance. There's another aspect of mathematics coming into the picture as far as the cricket is concerned. Let us say now health sector. Health sector. In case of the health sector, all these tests, whether it's blood test, ultrasound, ECG, they are all based on the mathematics. Okay, so if you just say your ultrasound, okay, so what it does, it gives you some kind of image. So there are the image analysis, Fourier analysis. So there are all mathematical techniques which you can analyze the images. Then accordingly, by looking the image, then the person, clinicians, they conclude it. Okay. So similarly, your ECG, it has a particular pattern. Wave-like phenomenon. Wave-like, you must have seen the electrocardiogram, the diagram. Okay. Again, all these integral transform techniques, they are used for analyzing this one. Wherever there is some change, then it's noticed accordingly, it predicts something is wrong. Again, this is, then you must have seen the artificial devices like oxygenators, dialyzers, okay, for dialysis. They are all based on the fluid dynamics concept. Even when you have the varicose in your legs, then what they do, when you go for the test, they inject the dye Okay, and then they inject the dye in the tube. They look how this just dispersing it, and they have the mathematical model for it. Okay, so these are some basic applications or mathematics on which these tests are based. These are simple ones, but complex ones because you cannot perform everything experiment on the human body. I just use the example of the brain. You cannot penetrate anything, electron from here. You cannot penetrate. Just say your skull is very hard. You cannot penetrate anything. But the physiologists, they measure it. What is the inlet from this side? What is the coming out? Okay? On the basis of this information, they develop a mathematical model, some diffusion model, and they calculate how much of, for example, in oxygen going to the cell, whether it's supply, enough supply, then they correlate with the blood flow, and then they try to find whether what is some abnormality in the brain itself. If time permit, I will take the mathematical model at that. Okay? So communication, you can just see. Communication, you are fortunate today. If you just look the 3 decades report, there was no mobile. Even I just put you to my time 40 years back, for example. Forget mobile, no telephone. Even if you book the telephone, for landline telephone, you have to walk. Then just look the public telephone. Okay, there is no communication. Nowadays you are so fortunate, everything is in your hand for the communication now. Have you ever realized how this communication goes? How this message are transmitted so that whether it's in your WhatsApp, whether your email, how the communication is taking place. How the security is maintained into it. Okay? So all these things again involve, as far as the communication is concerned, first the transmitter message, this itself, if you just look at, then they decode it, what you call a now new area which is known as the computer science cryptography. And it's based on it uses the basic concept from the algebra, okay, finite field and so on. So this is essentially communication. Insurance sector. You know how to decide the premium? Insurance. Insurance sector, how to decide the premium. Okay, this is one of the important aspects of mathematics. That premium will depend uncertainty. Okay, various uncertainties, and like whether for fire hazard or for health hazard, all insurance, what is the premium, all it depends. Again, mathematical models are there to all into it. Security system, I've already talked about. Software industry, you are familiar, each one of you. All software, when you write the algorithm, just see, I just give you a simple example. You have the two algebraic equations, two linear algebraic equations. 2x plus 3y equal to 7, take this to other one, and take the 5x plus 7y equal to something. And you are solving these two. These two, for particular values of these coefficients, you can solve these two equations very easily on the hand. Okay? But you would like to solve this for the 1,000 sets of coefficients. They may not be fixed 2, 3 and so on. How to do? Every time you are not going, either you do yourself every time, doing your complex things. So what you will do, you will write this one, you will solve these two equations for x and y, and then you write a set of instructions so that you can put either in your calculator and just by giving the values of the coefficient, you can solve it. So this simply, whatever the set of instruction in order to solve this problem is known as the algorithm. Okay? So simply you have the two equations, you have the method, you have the final x equal to y equal to, depending, even if you take the general equation a1x plus b1x equal to c1, a2x plus b2y equal to c2, solve the for any coefficient of a1, b1 and a2, b2. Okay? And that's what we call the algorithm. And these algorithms you will find in the then you write a program again. Okay? And these programs, now I think this is a part of your daily life today. Whether you go anywhere, whether you go in the bed, whether you go in the hospital, everywhere software is used, whether it is in the railway, and go take anything. Nowadays, even when you are putting your electricity bill online, it's all involved your algorithm itself. Okay? I just now another one is the elections. Now elections have been announced. You must have seen for parliament election must be announced, and you may be surprised. आपको लग रहा होगा मैंने आज इलेक्शन की कैसी बात की. Just see you must be hearing on TV nowadays, newspaper also, exit polls, opinion polls. किस पार्टी को कितनी वोट मिलेंगी, किस पार्टी को कितनी सीट मिलेंगी, who will win. ओके? तो कैसे करते हैं? कभी सोचा आपने? अखबार वाला भी क्या लिखता है कि they have done a survey. They have collected sample, sometimes 100, 200, 1,000, 10,000, depending on the region. They take the sample and they analyze this sample. There are the techniques by doing mathematics में statistics भी है. तो they are the statistical techniques what called the sampling theory. And we made the inference out of it using the probability theory. कि किसकी probability ज़्यादा है, जो सर्वे करके हमने जो डेटा कलेक्ट किया है, we analyze it and we just look. We just look at how much, which party will get how many seats, who will win. Again, this is the basic underlying idea. Well, yeah, just to very fine mathematics goes into it. And second one, nowadays everyone must be buying online from Amazon. Have you ever thought how the mathematics coming into the picture? सोचिए, अमेजोन से जब आप बाई कर रहे हैं, अमेजोन ने जब शुरू किया होगा, ओके, तो अमेजोन के पास ये तो नहीं कि बहुत बड़ा वेयर हाउस है, हर चीज रखेगा वो, हर चीज तो उसने स्टोर की हुई नहीं है अमेजोन ने. What is how it works? This model. तो अमेजोन ने हर चीज नहीं है उसके पास, पर लेकिन उसने कुछ लोगों को अपने नेटवर्किंग की हुई है, उसने अपने साथ जोड़ा हुआ. जैसे ही आप ऑर्डर प्लेस करते हैं, वो तुरंत उसको डायरेक्ट करता है और आपके पास चीज आती है. तो what are the goals? What are the conditions? As far as the consumer is concerned, he has to get the things at a cheap, much cheaper rate, at a fast delivery. Okay? So what is involved? Optimization, networking. Okay? So see the type of, and then supply chain management. All these mathematical models, operational research, they are involved into it. Similarly, all e-platform, they work on the same simple principles. I tell you, all use the same mathematical concept, which is using from the network theory, optimization, operation research. They use these all concepts into it. And then see the another example is Uber, and I'm sure many of you may be using Uber or Ola. If you have not used, I think you will have an opportunity. But question is how it works, Uber and Ola. Okay, they have the simple platform. Simple platform, you place the order, you get the ride. But how it works? Okay, the idea is this again, okay, it's a multi-fold problem. User as a consumer, driver, and then the Uber itself. Okay, then question arises, how it works? Your consumer idea, you should be able to get the ride very quickly at the same time. Then Uber idea is that all drivers, they should get the equal opportunity. Every individual should not be getting the business every time. Okay. Again, it's a optimization problem. Operation this one, and then they look the nearest driver should be able to reach as quickly as possible. He should be able to travel the minimum distance. All maxima minima concept from the optimization network theory again come into the picture. Into it. Simple mathematical models are there, come into the picture. I am just giving you just broad idea, just to highlight each one of you. कि जब यहाँ से आप जाएं, अभी I am sure most of you are either in the class 11th or 12th. जब आप जाएं तो आपकी के लिए ये नहीं है खाली आपके लिए जेई या इंजीनियरिंग ही अवेलेबल है सोसाइटी में. आजकल इतनी अपॉर्चुनिटी है आपके लिए करने के लिए, इतने मौके आपके लिए हैं करने के लिए यहाँ से जाने के बाद, वो सब आपको. Then see the transport example I have already given. Nowadays you must be hearing artificial intelligence. Artificial intelligence and machine learning techniques. What it does? I just give you a simple example. जब आप रास्ते में चलते हैं, गूगल की ऐप खोलते हैं और आपको कहीं जाना है, तो गूगल मैप बताता है कि किस डायरेक्ट कौन सा रूट फास्टर है, किस पे ट्रैफिक है, किस पे नहीं है. ओके, आप इस डायरेक्शन से जाइए. अब रियल टाइम में कैसे बताता है गूगल, कैसे करता? तो अब इसका ये है, एक तो गूगल के पास पूरा हिस्टोरिकल डेटा है, मतलब अभी तक जो गाड़ियों का क्या स्पीड से चलती हैं. एट द सेम टाइम दे हैव द जो जिस रूट पे आप चल रहे हैं वहाँ की रोड्स के बारे में पता है, क्या क्या इंटरसेक्शंस हैं, क्या क्या चौराहे हैं, क्या लेंथ है. एट द सेम टाइम जो जिस पर आप देख रहे हैं आपकी तो करंट स्पीड बता ही रहा है. एट द सेम टाइम यू मे नॉट बी सरप्राइज, गूगल है द हिडन थिंग्स. आपका एंड्रॉइड टेलीफोन जो होता है वो गूगल का होता है. इवन इफ इट इज ए क्लोज वन, बंद है बिल्कुल आपका, तब भी स्टिल इज ट्रांसफरिंग कंटिन्यूअसली डेटा टू द गूगल. केवल एंड्रॉइड ओनली, नॉट द एनी अदर वन. एंड्रॉइड दे हिडनली आल्सो दे ट्रांसफर योर डेटा. कि जहां भी अगर वो बंद करते हैं, अगर तो आगे वाली गाड़ी में भी चल रहा है तो उनको वहां की आगे की स्पीड भी पता है. इस सबको करते हुए दे यूज दिस न्यूरल नेटवर्क टेक्निक. Immediately they have the historical data, they have the current data, and they immediately they predict okay, which direction you must go. Okay, so this is, and again the everyone is hearing with the AI, but my underlying idea is this: AI is subject to your data, because what is involved in the AI? You need the two things. One is the physics and the data. Two things. Underlying physics and the data. And depends, for example, if there is no data, then it will be dominated by the physics. If it is the big data, forget the physics, it will not consider that physics at all. It will predict the behavior based on the data set. Okay? In the middle path, either it will use, if you have the equally the data, some physics also, then actually it will optimize. That's what you have the underlying idea of the artificial intelligence. I will not go into demonetization. I think it's old term, so it's already a great deal of mathematics, GST, all those things. I just take you a very simple model now, couple of models. See the simplest model you must have done in the either in your class 11. You know the free falling of a ball, you're just dropping freely. Okay? And simple model you already familiar with, v square equal to u square plus 2gh. You are familiar with this one, v square equal to u square plus 2gh. U is the initial velocity, please listen. Where u is the initial velocity, v is the terminal velocity, h is the height to which is falling. It has the three parameters, u, v and height. If you know any of these two, you can predict the third one. In case if you know the initial velocity, if you know the height, you can compute the terminal velocity. Okay? It's a simple model itself which you are all familiar. And it has a very wide application at the same time. Okay? Another simple model which you are already familiar with, dx upon dt. This dx upon dt equal to speed. You already know. Dx upon dt equal to speed u. Okay? When you integrate this, what it gives? X at the time t plus t equal to x equal to at the time t plus u times delta t. Okay? It's a simple first order equation. And you can solve this one that initially, for example, let us see this diagram. If you know the initial position at the point this one, t naught, and then you can calculate the position of the next particle at time delta t, 2 delta t, 3 delta t. Okay? You can calculate these positions at the different times. Okay? It means if you know the initial velocity, if you know the initial position, you can compute the positions at various times. Conversely, if you know the position of these particles, then you can compute the point from which is originated and what is the rate at which time. It means one problem, you know the initially, what we call the mathematically a forward modeling problem. In case if you know these measurements, then would like to retrieve this one. This is called the inverse modeling. One is the forward modeling, other one is the inverse modeling. These are the y, simple model, dx upon dt equal to u. Okay? And this, but it's a very wide application. It has the control problem also at the same time, you can control it. But what are the applications? I just give this some of the few applications of it. For example, if the dust is coming from the Rajasthan during the summer, whether it's coming to Delhi, how to do? You know the dust coming to this one, you will simply can treat this one. Look back what is the trajectory of it, whether they are starting the particle from the desert, some of the places, whether they are able to reach Delhi or not. Other one, when you must have seen in the pollution in Delhi, during the around Deepavali, and you see the stove burning, okay, and everyone have just talked that the pollution at that time is because of the crop burning, okay. In that case, again, whether it was coming to Delhi or not, again just you are looking the trajectory, okay. So that's what it is. Again, this has the number of applications. Now, there's another problem. This one, throw over the inclined plane. This concept, you can generalize. I already explained how we can use this one, throw over the inclined plane, or we can correlate with the projectile motion. I have already explained this one. If anybody has a question or doubt, please. अगर आपको कोई दिक्कत है, अगर कहीं प्रॉब्लम आ रही है तो पता कर सकते हैं, मुझे रोक सकते हैं, ठीक है? तो and this one, then again, projectile motion itself has the another application, satellite. Up launching of the satellite, you must have seen the बंद कर दें. अभी आपने मंगल 3 देखा होगा, लैंडिंग ऑफ मून है, लैंडिंग देखी होगी आपने चंद्रयान 3 की. उसमें ये देखिए कितनी फाइन कैलकुलेशन सिखाई है, किस तरह से आपका ट्रेजेक्टरी उसकी पार्टिकल की जाती है, और नीचे से देख रहे हैं आप तो किस तरह से कंट्रोल कर रहे हैं एक पोर्शन ऑफ द सेकंड कि अब लैंडर जो है कब टच करने वाला, कैसे नीचे जाने वाला. दिस सम सो फाइन कैलकुलेशंस आर डन, दिस ऑल यूजिंग अ मैथमेटिकल, जस्ट लुकिंग द ट्रेजेक्टरी इटसेल्फ कि किस तरह से ट्रेजेक्टरी जा रही है उसकी. तो दिस ऑल यूजेस द एग्जांपल व्हिच आई जस्ट गिवन द, this is of course simple example, simple model which I have given this one. You are just looking the trajectory, how the particle is going, how this one is going. This simple one. Okay. Otherwise, in general, as far as the satellite problem is a very complex. It's a design. Whether the design should be able to sustain it in the different environmental conditions. You need how much even type of the heat is required in order to put into his space. All these things they require again the mathematical.
अच्छा, लाइट कट मार रही है तो बताए थे आप, बताया तो कोई बात इससे क्या पूरे कट मार रही है. चलवाना ऐसे
आप आदेश बोलने वाले हैं, जितना आप आदेश करेंगे तब बंद कर देंगे हम तो. देखिए सिंपल मॉडल, ये देखिएगा, ये यू मस्ट हैव सीन द पाइप में फ्लूइड कैसे बहता है वन एंड से अनदर एंड। क्या कारण है कि वन एंड से अनदर एंड फ्लूइड जाता है, फ्लो होता है, प्रेशर ग्रेडियंट। ओके, तो यह द प्रेशर एट वन एंड, यह द प्रेशर एट द अदर एंड। ओके, लेकिन जब ट्यूब में देखा, शुरू में अगर ये है, जैसे जैसे शुरू में तो वॉल आपको रेजिस्टेंस करती है। ओके, एंड देन सफिशिएंट टाइम के बाद बिल्कुल आपका वेलोसिटी प्रोफाइल फुल, जिस पर कि वॉल का इफेक्ट नहीं होता। सी द सिंपल मॉडल, इनिशियली wall is trying to oppose it, put the resistance, but after some time, sufficient time, you have the wall does not affect it. You have the fully developed problem. And this simple model, you see the type of the application. When you are taking the bath in the morning, and just see where you have the pressure maximum. जब आप टैप खोलेंगे तो कहाँ आता है? सेंटर में आता है। That is the way reason behind it. This one, this simple model. But जब भी each one you all इस गेट से अभी आप निकलेंगे, तो ये बताइए तो कौन पहले निकलेगा यहाँ से? हैं? जो वॉल के साथ होगा या बीच में होगा? हैं?
जो वॉल के पास जो
वो कैसे निकलेगा? वॉल के पास होगा, जो बीच में होगा वही move faster. See the direct application of this simple model. When all of you come out here, this one, then wall will put so much pressure on it. This one, it will try, उसको निकलने का मौका ही नहीं मिलेगा, बीच वाला निकल जाएगा. Okay? This one. Again I skip. You must be having the tea in the morning. और एक पानी तो दूध तो डालते होंगे आप. ये simple another model है. And so physics में also you must be doing the experiment to the physics also. Heating from the beaker from the this one. The type of the convective motion. You have the simple model here, and this has a very wide application in the society. I just give you one last model in the biology before I close. See the application medical science I have already talked about little bit. I will not go into detail. Again repeat it. But I just see the how much perception is important. For example, somebody is doing the training from the commerce, someone has from the science, someone has from the arts, liberal art. Perception for a given problem is very important. For example, if you just propose a problem, for example, you like to just say to a mechanical engineer how it thinks about his body. He will simply say that body is a machine where the various forces are acting on it. A person, just see the simple case. If you go to a mechanical engineer, he will be looking at the body, a simple machine where various forces are acting on it. On the contrary, if you go to the chemist or chemical engineer, what he will say is a chemical plant where chemical reaction and diffusion processes are taking place. Same problem if he proposed to the electrical engineer, he will say it's simply an electrical circuit where you have the inductance, capacitance and the resistance. And all of these, they just look, they will give you the same simple answer at the end of the day. The perception is very much important, how you are looking at this problem itself. What is your background, what is your basic training into it. I just give you last simple model which I talk about the brain before closing. It's a which you have you done the differential equation calculus in the so far? आप लोगों ने किया calculus अभी तक? हाँ? कर लिया ना? लिटिल बिट की, अभी डिफरेंशियल इक्वेशन नहीं किया आपने? चलिए कोई बात नहीं, आई जस्ट गिव द एप्लीकेशन ऑफ डिफरेंशियल इक्वेशन. As I was mentioning, the brain is a very hard skull. Nothing can be penetrated into it. And in the 1909, being a physiologist who did not have any background about the mathematics in those days, he just proposed a very simple model at that time, just to see how the blood is regulated in the brain, how the oxygen is supplied to the brain cells. Cells को sufficient energy मिल रही है कि नहीं मिल रही है. Okay, simple model. It cannot be penetrated. Cannot, nothing can be measured. What is the information they have? They measure simply. यहाँ दो ट्यूब होती हैं आपकी, एक अंदर जाती है ब्रेन में, एक बाहर आती है. Simply अंदर जाती है जो ब्लड फ्लो रेट, और अंदर कितनी ऑक्सीजन जा रही है और बाहर कितनी ऑक्सीजन आ रही है और बाहर क्या ब्लड फ्लो रेट आ रही है, और कुछ इंफॉर्मेशन उनके पास नहीं होती है. बाकी की इंफॉर्मेशन जो है अंदर से मैथमेटिक्स से निकालनी होगी. ठीक है, तो उन्होंने ये सोचा कि जो जब आप अगर एनाटॉमी का स्ट्रक्चर ब्रेन का देखें, बहुत सारी ट्यूब्स होती हैं, बहुत सारा, तो उसमें क्या है कि हर ट्यूब में ब्लड रहता है, उसके सराउंडिंग सेल्स होते हैं. तो व्हाट इज पॉस्टुलेटेड ए सिलेंड्रिकल ट्यूब कैपिलरी जिसमें ब्लड रहता है, उसके सराउंडिंग एक सर्टेन रीजन जो है जिसमें कि वो सप्लाई कर सकता है. ही जस्ट थॉट ऑफ ए डिजाइन a capillary surrounded by a tissue cylinder, and he thought that all brain, in the brain, such small units, they are homogeneously placed into it. So he just taken a simple, a very single one, जिसमें कि ऑक्सीजन इस साइड से जा रही है ब्लड से, और यहाँ से ऑक्सीजन डिफ्यूज होती है, सेल में कंज्यूम होती है, and this is the radius, inner radius. इससे एक आउटर रेडियस है जहाँ तक की सप्लाई हो सकती है, और उससे सिंपल उसने मॉडल बनाया, सिंपल खाली, और ही नोट के सिंपल. आई जस्ट विल नॉट गो टू दिस. दिस इज द डिफ्यूजन टर्म, दिस इज जस्ट ए कंजम्पशन, एंड सिंपल ये सॉल्यूशन आ जाता है. इफ यू नो द व्हाटएवर एट द एंट्री, इफ यू नो द कंसंट्रेशन इन द ऑक्सीजन जो एंटर कर रही है यहाँ से, देन कितना कंज्यूम हो रहा है, क्या रेडियस है ट्यूब का, उससे कैलकुलेट कर सकता है कि सेल में कंसंट्रेशन कितनी है. ओके, एंड दिस इज स्टिल ए चैलेंजिंग प्रॉब्लम टुडे. मच मोर कॉम्प्लिकेटेड मॉडल्स हैव कम अप. स्टिल दिस इज यूज्ड स्टिल टुडे. दिस सिंपल मॉडल स्टिल टुडे इज यूज्ड इन द क्लिनिकल एप्लीकेशंस to study how the blood gets regulated inside the brain, and how to identify the injured place, where which portion of the brain is not able to get the sufficient supply of oxygen and so on. Okay. So with this, there are number of applications, atmospheric comfort, atmospheric science. I could have given this one, but I just stop it here. अगर आप लोगों को कोई क्वेश्चन है, क्वेरी है, पर यह है कि ये आपको बैकग्राउंड देगा कि अभी 11th 12th में जो भी आप कर रहे हैं, essentially you are doing whatever you are reading in your textbook based NCERT books में, जो कि standard textbook है. This does not provide you कि आपको आगे क्या क्या करना, क्या क्या एवेन्यूज अवेलेबल होते हैं. ओके, क्यों अभी तो क्या है, माउथ वायरस से आपको पता है, दोस्त ये कहते हैं IIT देनी है, JEE देनी है या नीट देना, बस ये 30 अपॉर्चुनिटीज आर अवेलेबल. बट इट्स नॉट लाइक दैट. देयर आर नंबर ऑफ डस्ट ऑफ अपॉर्चुनिटीज आर अवेलेबल, जहाँ की आप फिजिक्स, केमिस्ट्री एंड मैथ्स यू कैन यूज इट. ओके, और engineering is not the only career, or medical is not the only career. There are many careers, they are open in this one for you, they are waiting for you. Number of institutes have come up like ISER. There are number of institutes besides IIT, there are number of other institutes also. I mean, open it. Even after that, like space program, you have the IIST in the Trivandrum. They have number of opportunities are available for each one of you, and this will provide you now, because time has changed, new technology has come up in looking at the artificial neural network, data science, many things have come up. Okay? With this, thanks everybody. And if you have any question, any doubt, I will be happy to answer.
मेरे को खाने के लिए
Do you have any doubt? Anybody want to ask anything?
क्या लिख रहा पहले तो
We are so intelligent, nobody will ask. We learned a lot. Thank you so much, sir, for your knowledgeable lecture. So, before starting with another lecture, and then we will go for your lunch. So, for that, there is a 5 minutes break. If you want to go to washroom or you want to drink water, you can go, please.